Let's now look at how we hydrate an alkene. And we can do hydrations of alkenes. So let's now change our acid a little bit. We're going to treat this alkene with water because we want to add water. And when I say add water, I mean H on one side and OH on the other. Okay, so we're going to treat this with water. Water alone will not do a hydration. We need acid in here because acid is going to protonate our alkene. So what we're going to do is we're going to mix water and a really strong acid, something like sulfuric acid. Remember, when you mix water and sulfuric acid, you no longer have sulfuric acid. It gets really hot and sulfuric acid forms H3O plus. Whoops. H3O plus. So here we are treating our alkene with the strong acid. With HCl, we protonated the double bond. With H3O plus, we will protonate the double bond. Now this is going to form a carbocation. I'm going to go straight to the more stable carbocation, the secondary carbocation. Now when you do this, you have acid and water. You typically have a lot more water than acid. So even though I've shown the formation of H3O plus, there's still lots of water floating around. It's not like all the water is gone. There's still plenty of water. Water is a weak nucleophile. And fortunately, carbocations are great nucleophiles. Very strong nucleophiles. So what are the two fates of a carbocation? They either get attacked because they're strong, not nucleophile, crazy. They are electrophiles. It's a strong electrophile. It will get attacked if we have any nucleophiles around. And we do. We have lots of water. So we attack. We form this as an intermediate. Our reaction is not complete because we never finish with charged species. So we need a base to deprotonate this oxygen. Remember, this oxygen has a positive charge, is asking for something to give it electrons. And the way we'll give it electrons is by attacking the hydrogens, and we'll give it the electrons in that OH bond. And now, once we complete this step, what we've done is we've added water. We added H to one side. I haven't shown it, but there's an extra hydrogen over here compared to what started on that carbon, and there's an OH on the other side, on the more highly substituted position. So we went through a carbocation, and so we get the Markovnikov product because the carbocation formed in the best position it had. This is a secondary carbocation, and so we get the Markovnikov product. This is really very much like adding HX to an alkene, except for once we form our carbocation, we have attacked by water instead of a halide. And so it's very much the same mechanism, and so we use the same terminology, Markovnikov product, carbocation stability, all these different ideas. So that's how we do the hydration of an alkene, addition of water to an alkene.